Hi, ladies and gentlemen. I'd just like to say welcome, welcome to Science Explained with Mr. K. Thank you very much, ladies and gentlemen, for the love that I've been getting from you. I've just been given an award for getting 100% in 2019 and 2020 for physical sciences. That is a very big achievement, ladies and gentlemen, and I couldn't have done it without the response, without the cooperation of learners that I teach. It can also be the same for you, ladies and gentlemen. It can be the same for you out there. You can also achieve the best results. It's just a matter of understanding theory. You see, science is not just about doing the calculation, getting to the answer. No, it goes further than that. Hence, I normally use the theory approach, because if you understand the theory, guys, everything then makes sense. Like, you will have a specific reason why you're calculating a specific variable. Otherwise, you are just calculating and there's no interpretation. Hence, some of the questions that you will get, they would give you something like, okay, out of the answer that you calculated, then come with a conclusion, which becomes something that is very difficult, especially if you do not understand the theory behind your calculation. That is why I'm here, ladies and gentlemen, to assist with the theory.
Hi guys, I would like to welcome you to Science Explained with Mr. K. Before we start with the show, I would like to share a few positive thoughts about challenges we experience. Questioning. Curiosity has its own reason for existence. One cannot help but be in awe when he contemplates the mysteries of eternity, of life, of the marvelous structure of reality. It is enough if one tries merely to comprehend a little of this mystery each day. Words by Albert Einstein. Just food for thought.
Right, guys, today's lesson is going to be on chemical bond and the different types of forces that we get. Okay, you would realize that for you to understand the different types of forces, you need to understand the work from grade 10 and then you move to grade 11. So that is the most important thing. Okay, now when we talk about chemical bond, we are talking about the type of a force. I want you to understand, guys. It is not just a bond. It's not like just a bond, but it is the force that is holding the atoms of the elements together. Atoms, it's holding those atoms together. The reason why we have H2O, that's because the hydrogen atoms are held together with the oxygen atoms by a force. Now, this type of a force is the intramolecular force. Intramolecular force, or the interatomic force. Now, when I say that, guys, the word intra means inside. The word interatomic, because there's an atom involved there, it means it's a force that is holding the atoms together. The reason why we have a compound is because of these types of forces. I want you to fully understand that. Now, we have the different types of the bonds, okay? Chemical bonds, which is the covalent bond. Now, the covalent bond would be the sharing of electrons between nonmetals. You need to understand that nonmetals can only accept, right? So because they can only accept, the only thing that they can do, if it's both nonmetals, we can only share electrons. I want you to fully understand that. So hence, this type of a bond where we share electrons between nonmetals is called the covalent bond. Okay, and then we also have another type which is called the ionic bond. Okay, ionic, from the word ion, automatically tells you that there's some form of ion exchange. Okay, but in this case, I am forming an ion, but in the process of forming that ion, I am transferring an electron from one metal to another. Okay, so for instance, when we talk about an ionic bond, We are talking about you are transferring an electron from where, guys? From a metal. In other words, it can be any metal, group 1, group 2, group 3, any metal. You can choose any metal, and then we're transferring that to what? To a non-metal, because a non-metal can accept electrons. Is that clear, guys? So just be aware that it involves a situation where a metal is going to transfer an electron to a non-metal, and at the end of the day we end up in a situation where a non-metal is very happy because now it's going to behave like the nearest noble gas. Because remember, your noble gases are balanced, they are straight, there's no need to accept or transfer any electrons. They are fully balanced. They are basically satisfying the octet rule. Okay, so meaning their electron or the energy level, okay, the energy level is full. Okay, we are not transferring, we are not receiving anything. So those are noble gases. So all these elements, guys, they want to behave like the noble gases. So hence they will be very happy to accept, or they will be very happy to transfer an electron. Okay. Now, the last one would be the metallic bond. A metallic bond is a bond that happens between a metal and a metal. Okay? So, this type of bond is not a common type of a bond. It happens in other words, you have to force protons, because come to think of it, it has to do with protons. Because you're taking a metal and a metal, you are forcing these two to bond together. To do that, there must be a cloud of electrons. You need to create a condition where there's a cloud of electrons that are between these specific metals, so that there's that allowance for a metallic bond. Otherwise, guys, if you just take a metal and then you try to bond them together, that is not going to happen. This is only possible in the presence of the cloud of electrons that are surrounding these two metals together.